Hi, my name is Jordan Vigner and I teach at East Ascension High School in Gonzales. I'm a first year geometry teacher and I teach 11th grade. We use the Eureka math curriculum and the lesson we are doing today corresponds to Module 1, Lesson 25, which is triangle congruence proofs. However, as you know, our students are struggling with a lot of educational gaps due to the pandemic, especially in math. So for this lesson, I have provided some supplemental materials to help get students there, whereas Eureka has them simply writing proofs from scratch. My objectives for my students today are that they're able to determine if two triangles are congruent, justify by using the appropriate congruence theorem, and fill in the blanks into column proofs. Prior to this lesson, my students and I have created these flip charts for the congruence theorems, which include the titles, pictures, and definitions to help them learn these. Additionally, we have practiced applying those theorems to figures. As a part of the scope of this course, we also defined congruency in terms of rigid motions, and this made the transition from our previous unit to this one very smooth. As a part of the lesson that you will see, we will be working in Desmos, and students will work with a partner to apply given information to a figure of triangles, draw that, and then determine if they're congruent. I have a few modifications that I will make to this lesson. As we are doing the Desmos activity, I will have my teacher dashboard on a tablet, and I will be able to monitor which students are mastering the objectives and which are not. Those who do master the objective will move on to filling in formal two-column proofs. Those who do not, I have these card sorts in which they have manipulatives to kind of help them see these proofs before writing them from scratch. I hope you enjoy.
Go ahead. The sides are congruent. How many sides? 3. What else? The angles. How many angles? 3. So you're looking for those specific parts here. Then we have our theorems. We have our shortcuts. What are those theorems? Start bouncing them off. What are our shortcut theorems? Angle, side, angle is 1. Thank you. Angle, angle, side. Side, side, side. Side, angle, side. And hypotenuse leg. When do we use hypotenuse leg?
When it's a right angle.
When it's a right triangle, which means it has a right angle.
So then there's the two.
This is angle, side, angle. Absolutely right. Let's come back to the right. It does have right angles, but if I have one angle that's 90 degrees and another angle that's 90 degrees, are they congruent? Yeah, so even though it's a box, that still is the same thing as drawing a little arc. Okay, so what would number 1?
So that would be angle. And then since
Wouldn't
Q
these
and S are one line,
here.
you put a line right here.
And what do you call it?
So that would be
Angles,
side,
and we know that we're
side,
looking
angle,
for.
side. Yeah, because then
So side angle side is
another
here,
segment
because
that
that
makes
reflexive
that
is that second pair of sides.
another
Yes.
side.
Verticals. What do you know about verticals? They're equal to each other. What's another word for that? Congruent. So what would the pair in triangle 1 be? And which theorem would you use here? Absolutely, it would be angle, side, angle. So remember, look at your flip chart. Remember angle, side, angle. That side has to be included.
So if it was right here, then it would be angle.
Yes, absolutely. If it was right there, it'd be angle, angle, side. Angle, side, angle. But what's the difference?
It's not included.
It's not included. So which one would this pair be?
That would be, that'd be angle, angle, side.
Absolutely, angle, angle, side. Does that clear things up?
That is equal.
What's that? Explain to me what that is. Reflexive property. Can you name that segment for me? AC. So AC is congruent to itself. Good. Now what?
I don't know with the sketch.
Yeah.
Here's your, so you can put a marking there because we're looking for markings on our sides and markings on our angles to note congruency. So great. Now look at the given underneath. Read the first statement when you.
AC bisects angle BAD.
Great. Stop there. Bisects, what does that mean?
Bisects
two equal parts.
Splits into two equal parts. So find angle BAD for me.
Right here.
Yeah, do y'all see that? So it splits into two equal parts. Yeah, so can you do markings there for me?
BAC and
Uh-huh.
CAD.
Yay, absolutely. So now you have two markings there, and you have one more piece of given information.
AC bisects BCD.
Awesome. So what do you mark there? Absolutely. It is absolutely angle side angle, but I want to finish here real quick. Yes. So that angle is bisected as well. Does that make sense? Lovely.
Angle side angle, but this could also become angle side angle since they're vertical.
Absolutely. So it's asking for side angle side.
And it can't be that because that's side and side, and that's a hypotenuse.
Good.
So it has to be one or
Let me stop you for 1 second. You're absolutely right on all of those. You got all of those right. Are we up to speed there? Look at the third one for a second. Look at the third one for me. Those two angles, what do we know about them? What those are? They're right angles, meaning they're what? 90 degrees. If I have one angle that's 90 and another angle that's 90, would you agree that those two angles are congruent?
So whenever they share line.
Yes. So can I count that as an A?
So it's side, side, angle, side.
So notice, I can count that as an A. So what happened in here? Like reflexive property. So I put
Okay.
what have we got?
So for A and C bisects,
Uh-huh.
put the line there.
Okay,
for-
let's
for-
start with this line. Why did we put it there?
Because this is point A and C, and bisects directly in the middle. That's what.
So, I think you are jumping the gun here. So before we read our given, we can put this mark here. Do you remember what that's called? Those two triangles share that side. So we put that mark there because if we split those triangles apart, those sides are equal to each other. They're both AC. Do you remember what property that is?
We just talked about it. And I
Uh-huh.
forgot it.
Two things that are the same, like looking in a mirror.
Congruent.
Reflexive property, meaning something is congruent to itself. So I'm saying we put this mark here because look, if I were to look behind you real quick, if I were to take those triangles and split them up, here's AC, here's AC. It was one side, I split them up. They have to be the same length. So that's what that is. So that didn't come from the given, that came from your brains. Now we look at the given. And what is BAD? What kind of object is that? An angle. Show me angle BAD. BAD right there. What does bisect mean?
Interrupts. Like, isn't it like it splits it into two?
Two what? Keep going.
No,
I got
like,
you. No, it splits it into two. Two what? Two. What's specific about those two things that splits it? Equal parts. Yay, two equal parts. So if I have angle BAD, in this segment here splits it into two equal parts. Can you mark what those two equal parts are?
is it like each angle?
Yeah.
Or each side?
The top angle and the bottom angle. Yeah, that's great. You also could just put your little arch like that to save you some time. Yeah. But you're right. You're absolutely right.
And then for the
So do the same for the second part. What does the second part say?
AC bisects angle BCD. So it's the same thing.
Yeah. Great. So you've labeled your given. You've done your extra information from your brain. Are those two triangles congruent?
Yes.
You think yes? Well, why?
Wait, is it SSS?
No. Angle side angle.
Absolutely, angle side angle. Remember, SSS means three congruent sides. What we marked here was an angle bisector, so you have two angles. Angle, side, angle.
Then choose which postulate proves the triangle argument. Well, since A and C are reflective properties, that means they're congruent. So this is already got A like this.
And what is where are we putting two? It's 1/2. So what you're doing doesn't matter.
Come on, you can AC bisects angles BAB and AC.
And where else?
Yeah, so that's the side. These are congruent. Yeah.
And so what's the other side?
Let me get it.
Absolutely.
So, there's an X here, and these two angles share this line, so it makes it vertical. And they're across from each other. So if the two angles are across from each other, then they're congruent, which means that they're the same. So then it says QX, which is this segment. So you technically put a line here and here, but you don't really need all of them. And then the midpoint is this, so you automatically there. And then it says PR, so you have two angles here, and you use that one even. So if you would read it from yeah, so if you would read it from left to right, it would be S.
This information here, this given information.
You really don't need both sides, but both sides
This
are really actually going to be labeled.
X is the midpoint of QS. Can you show me what your midpoint is QS? Yeah. You see QS? If X is the midpoint, can someone come put 2 tick marks on the congruent segments? Go ahead, Blake. If X is the midpoint of QS, what does midpoint mean? It's in the middle. That means that we now have 2 congruent segments. No, put these tick marks. QS. Beautiful, beautiful. That is exactly the first part. Thank you so much, Blake. The second part, can someone read this one for me? X is the midpoint of segment RP. Here's RP. RP. X again is the middle. That means it splits it in half. Boom, boom. Okay, we dealt with our given. Is there anything else we see that needs to be labeled? Anything else we see that needs to be labeled on this diagram? Are y'all with me so far? The ones over here, I know y'all asked for 6. With me so far? And what did you just do? Beautiful. Did y'all hear what she said? She said these are vertical angles, and we know vertical angles are congruent. Beautiful. Now we have side, angle, side. Are we okay with that? Yep. Side, angle, side.
At the end of the lesson, students were given an exit ticket in Edulastic, which aligned to the objectives of the lesson. Some questions had students determining if triangles were congruent, some had them justifying why they were congruent, and some were actually filling out proofs. I determined that my students overall had mastered the objectives because there was a 71% average. However, I can look individually at which students did and did not meet the objectives and plan for the next lesson based on that. What I mean is that students who did meet the objectives will be able to move on and work in the Eureka workbooks on actual proof writing from scratch. I can provide them with a word bank to kind of scaffold that and build them towards a full paragraph proof. Those who did not meet the objectives will work with me in groups tomorrow, going back to that card sort, and I will be finding the misconceptions for them as to where they are getting lost. Hopefully that will help them see a proof better, and then I will have them working on 2 columns, filling in instead of actually writing from scratch. Something I would do differently is next time using this Desmos activity, I would like to have students self-check after each starter proof that they do, because next time I do this Desmos activity, I would like there to be a way for students to self-check after each question to make sure they're on the right track and they're doing things correctly. In this lesson, I had a lot of students raising hands, asking for help, is this right? And they couldn't self-check until the very end. However, due to timing, not all students were able to complete 15 starter proofs, so I would have liked them to be able to self-check after each question. I think this would have made the lesson run more smoothly, and it would help build their confidence to know each time whether or not they're on the right track. After the video portion of the lesson, we began filling in 2 column proofs in an I do, we do, you do type fashion. This allowed students to see a model, indoor questioning, and then try on their own. Additionally, we have created a proofs anchor chart with questions that students should ask themselves as they're going through a proof to help them think through it logically and to help them when they get stuck as they're working on their own. In the next lesson, we will return to the Eureka workbooks and begin writing proofs from scratch. As mentioned before, I will have a word bank if necessary, and after writing 2 column proofs from scratch, we will be introduced to paragraph proofs. And hopefully for my advanced students, the ones who really meet those objectives, I will challenge them to write a paragraph proof all on their own.